Well, hello. We're back. Excited about tonight. Been a interesting couple of days, and I've learned quite a bit in the last couple of days about RatOS and the way that Mikhail and them actually set this whole thing up and configured. So really happy to be back. Also have some new findings that I would like to share, and also see if we can get through a part 2 of setting up the actual firmware on the Raspberry Pi to recognize boards and to recognize the devices that you're going to connect. And so let's get going without further ado. Evening, or this is afternoon, where we? Yeah, it'll be a little bit earlier. So thanks for joining. Welcome. Very happy to have you here. Fire away on any questions you have. Happy to try and answer where I can. It's a very warm evening here from Abu Dhabi. And yeah, it's my last evening before the family returns. So from next week onwards, we'll see a couple of more noises. Well, yeah, a couple of more noises come around from the house, and kids will be back and school's starting. So a lot of things happening in the house, but we're going to continue. We're still going to finish this RatRig, and we're not going to rush it. We're going to do it in good time, and we're going to make sure that we cover as many of the bases as we can. But as tonight is really, I want to keep it as short as possible. Aim is to do an hour, might be about an hour and 15 minutes, but let's see. Hi Terry, how's it going? So what have I learned? Well, I've learned how to break BTT boards and how to fix BTT boards as well. Not that I didn't know how to, but I just didn't realize how much trouble you can get yourself into. So in our previous stream, we opened up the RatOS website, and I think maybe let me just bring some of that up right now so that you can see. We opened up the RatOS website. We got our Raspberry Pi software ready. We downloaded the RatOS image. We put the etcher in, got Balena etcher in. We put it on the SD card. We fired up the Raspberry Pi. We joined the RatOS hotspot, and then we clicked on this link, and we actually got into the Raspberry Pi and into the RatOS configuration steps, and we pushed firmware to the main board, and we pushed firmware to the little BTT42, the smaller breakout board that we're going to use, one of the tool boards. And things went okay, but it didn't go great, and some lessons learned. So first of all, if you've never really worked with Clipper, and this is your first time working with Clipper, and you're going to build a RatRig, but you really want to build the RatRig, I'm really going to recommend that you buy a board that is 100% supported by RatRig, right? It is so much easier, and it works so well, and you don't have to struggle to figure out configurations and things. Obviously, I've gone with one of the latest boards. Yes, I'm sure that this board will be in their configuration in the near distant future. They're busy. I know they're busy with it already. I think they're not too far from actually putting some of the configuration together for this board. But at that, if it's not there, it's a lot more work. Okay. And what I'm going to do tonight is pretty much show what I had to do to get this board to work. But it also will cover sort of, if you had chosen a standard board, how easy it would have been. Now, I know that if we go onto the website here, I want to touch two things over here. And yes, I have reached out to Mikhail and them on the RatOS, or put it this way, on the RatRig Discord, and I have informed them that they need to maybe just update their website just a little bit, because they are missing a couple of important line items, and they're going to. The guys, have got a lot on there. They've got the whole world looking at them, trying to do things. They're trying to test new boards. I don't know how their payment and structure works because this is all open source. So I'm not going to point a finger. You know, if you can't do a better job yourself, then rather just go with the flow. But they have done so much work as it is to get this to work well. And so we're going to just have a look at this item where it says supported boards, right? And in the supported boards, they have brought up a whole host of boards, right? Bigtree and Physec and Prusa. Typically, we've stuck to Bigtree Tech boards, and I also realized that they had a SKR3EZ. Now, this is the Octopus Max EZ that I've got over here in front of me. But the SKR3EZ is a board that I also have. So what have I done this week? I rebuilt one of my old Cartesian printers, ripped out my SKR3 board because I thought, great, I'm going to just use this board and demo it, and it'll be the easiest thing out, and we could just move forward. And so I actually put a Duet 3 board into my old Cartesian, and I installed Clipper the standard way you would do on most printers if you weren't going to use something like RatOS. So remember, RatOS is a derivative or a pre-packaged and configured Clipper that is built with an amazing amount of configuration and flexibility already put in place to make it as easy as possible for people to be able to get into the Clipper world, in comparison to something like Bamboo Labs, where you just put the printer down, switch it on, and within a couple of minutes you're printing. Yeah, still a lot of configuration. But let's get back to SKR3. So I took SKR3 and I put it down, and I thought, okay, I went through the initial pages and I did the installation, and when it was finished, you go to the next step, which is now to actually connect to the actual RatOS, and you get, yeah. Now I just want to come back to this 1 second. Just remember, if you click on this link, you didn't use the default name that they gave, RatOS, and you changed the name. Remember, you need to change the name of the URL as well. So I'm just going to copy this link. I'm going to paste it in my browser, and because I changed it from RatOS to RatRig, RatRig V-Core3.1, I need to change that number, just that portion of the name. When I push enter, it will bring me to the following area where you then get to choose your, this is a step where you actually get to choose your board. And over here I used the SKR3EZ, and I ran this. I'm not going to do it now again because I don't want to mess up my board. Next, I chose the tool board, which is the little tool board that I have over here, which is the EBB. And when it was all finished, it looked great. I thought, awesome. Next step. So the next step would then be to actually go to the actual mainsail interface, which it opens, which is this interface over here. And this is where we got up to last week, right? And I thought, okay, great. I'm now going to run it as if I was going to use this board. So let's carry on. And because we're building the V-Core3.500, the next natural step is to push the V-Core3.500. Now, I can tell you something before you push this button. You can get back to this stage. It's not very difficult to get back to this stage. But before you do that, I would highly recommend you go to machine on the left-hand side. You run the check for updates, right? Let it check all the updates. And if there are any updates, obviously I've now updated mine already. if there are any updates available, we're going to do them. Please remember, you need to run RatOS by itself first. If there's a RatOS update, run that one on its own first. When that's update, then you can click on them individually, or there will be a button down the bottom here where you can just say click on all and it'll update the whole lot, right? And it'll push even new firmware to the boards at this point. There are different conditions where it might not work 100%, but in general, it's pretty smooth, works fine. The software updates, there are a few minor conditions where the board firmware update might not work, but RatRig have got that covered in their documentation, so I'm not going to go into that right now. And by getting to this point and you've got that all up to date, then you can come back to the dashboard. Now, at this point, if we go back to machine over here, you'll see the host, which is the Raspberry Pi, and the Raspberry Pi is here. The Linux is running, everything is fine. And ideally, you should get something similar to this. But if there's errors, don't worry about it. You're going to be working on configuring the rest of the computer now. I'm jumping over my words. The rest of the Clipper firmware now. So let's go to back to the dashboard now. So once that's done, as I said, you're going to choose your different type of printer, and I'm going to use the V-Core3. So I'm going to push this button and it's going to run a macro, and basically what it's going to do is copy a couple of files across and move some files around and get everything ready for you to start your initial configuration, right? Now, you will most likely get this, and eventually I would assume it's going to now time out, right? And you will get a error in most cases, because you haven't really configured anything. You know, it's going to be looking for the board, and it's going to be looking for devices, and it's not going to know how to find them and where to get them, what to do with them. So what I'm going to do is I'm now going to go to the machine, and you will now notice that we have a couple of files that have arrived into this folder. And the most important one over here is your printer CFG. Please ignore this folder for now. I'll explain this folder in a couple of minutes, right? That was some pre-work that I've done before tonight, just to make sure we can actually get a little bit further than normal. But your next natural step would have been to have clicked on the printer CFG. And yeah, RatRig now tell you to go through the configuration and include and exclude whatever you have in your build that you're building, your RatRig printer, right? So remember I said we did the SKR3 EZ. So the first section says, which controller board are you using? Hey Franz. And if you look into this list over here, you'll see there's the SKR Pro, there's Octopus 11, there's Octopus Pro. Hold on a second. SKR3 is not available. Right. Why is that? Because that's the board I just flashed. It was there in the initial setups. Do me a favor, when you're choosing your board, go back to the original website. You can go and have a look under supported printers. Right? Under the supported printers, have a look at the printer that you're going to build and choose a board from this list, right? Because your board is determining which printer you can support as well. Let me grab the other board for 1 second, and I can just show you what I mean by that. I put it back here. Why would this board typically not be supported? This SKR3EZ, right? if you have a look on the SKO3Z, I'm going to put it like, hold it up over here. You'll see that this board only has 1, 2, 3, 4, 5 drivers, right? Meaning it can run 5 motors. And on the V-Core3, you've got 3 Z motors. You've got your Core XY, your XY motor, which is another 2, so you had 5 already. And then you still have an extruder, right, where the motor that actually pushes the plastic through. So what you really need to make sure is, do you have a board that can support all your motors? And by default, this board, as it is right over here, could never support the V-Core3. If you had to take this board and combine it with the little tool board, yes, you could actually do it. You could run the V-Core3 printer, because here's your 6th driver that you require. But because the configuration hasn't been made for that inside RatRig OS, they haven't actually given you that option up front, right? Now, I'm sure that they will at some stage bring it in that you can put this board in this list, and in brackets they're going to say, and requires the tool board, and then they'll give you the option to be able to actually run it that way. Because if you ask me today, I will be able to configure this board with this tool board, and I would be able to run this printer. But it's a little bit more manual customization. Okay, so just have a look which boards are supported for your printer that you're building. You will see there are different boards at different stages that they've planned for these different models. The ironic thing is the SKR3EZ isn't even in this list, because it was recently brought in, and I highlighted to Michael and them, this website is a little bit outdated, and they agree they will be updating it hopefully soon to actually show where does the SKR3 board actually fit into the whole picture, and where can you use it. But typically it would be used on the Cartesian printers, which, like the Minion, where you only need 5 drivers in total, right? So what I'm going to show you tonight is, even though I would have gone with this board, whether I go with this board or whether I go with this board, I'm still going to have to do configuration. And I'm not going to go buy Octopus Pro just so that we can follow 100% their documentation. But as we go along, I will try and point out where you could have stuck to the default had you chosen one of these boards. So coming back to this, I just want to close here for a second. Let's just say don't save. This is the error you would have most likely got. MCU unavailable to connect. Why? Because it can't find this board at this point in time, because it's configured to find a board which isn't there. Okay. So don't worry about this error. Once you've gone through this printer CFG, you'll start seeing different errors. Eventually what we want to get to is a point where we're actually going to get an error that's going to be like in a yellow box, where the MCU is going to shut down, and I'll show you that at the end and why it does that. So here we go. So if you were going to use one of the default boards, you would just come in here and say, you know what, which board am I using? I'm not using that board, I'm using that board. All right. And had you save and restart, it would then move on to the next area, and you would start finding less and less errors. But there might come up some more errors because you still got a whole bunch of other decisions to make in this file. But pretty much by unhashing that one little item, you would have actually been very close, if not already there, 100% ready to take your board and put it into the printer and start connecting doing your wiring, and then do your initial tests. There are, as I say, there's a couple of things down in the bottom file that you would have to double check, but you would have been very close. And that's what I really like about the RatOS. They've really done a brilliant design in the way that they've configured this. Okay, So how is Raymond going to get his board to work? I can't choose one of these, right? It's not going to work. So this is for the guys that have gone one step further. I'm going to decide to look at these boards and I'm going to say, well, you know what, the Octopus Pro, this version 1.1 board would have been the closest to this board, and I'm going to use this configuration, but I'm going to have to modify it. Right now, what I can do is close here, right, and I'm going to say, I can just say save and close. It's not going to make any difference because I'm not restarting. And if you go into the RatOS and you go to boards and you scroll down until you find that specific board, right? If you open up this file folder, inside there's the config, right? So if we click on config, and forget about the rest of the files for now, I'm not going to go into that, otherwise we'll be here all night. Here it is, the configuration specifically for that board, right? With TMC 2209 drivers installed. Again, stick to drivers that you know. TMC 2209. If you're going to go with the 5160s, then you're going to have more configuration, and you also need to know a little bit more about Clipper and that. So as a first time around, unless you've worked with Clipper, just stick to the normal drivers. They're good enough for 99% of us, right? So what it over here says is to override these files, we can copy this section and paste it into the main Clipper printer CFG file, and then we can modify it from there, right? If we modify this now over here, and we save, and we go back to the main file and we point it to this one, yes, it'll work. The problem is the next time RatOS has an update and there's an update to this file and you say update, it will wipe all your settings and you'll have to start all over again. Very important. Okay, so do not modify these files, right? They're there as templates. Okay, and in the case where you're using stock standard print boards, which are 100% supported, they're actually operational. They're going to work without you having to make any modifications. Okay. I'm going to not 100% follow what the RatOS team recommends here by copying this and pasting it into the main file. I'm just going to do a slight different variation. What I'm going to do is I'm going to copy this. I've created a new little folder for myself, which will not be overwritten when they do updates. And inside that folder, I'm going to create a file, same as what they had, config.cfg. Right? Inside my config.cfg file, I'm going to paste this. Right now, I'm going to build this file specifically for this board. Okay, and I'm going to do some modifications to it. So in order for me to do modifications, again, just so that I know where I am, I just did this, and I'm going to say rs custom Octopus Max EZ. Right, this is just for me. Oh well, I can just say, you can type anything you want. It's just a comment so that I know where I am. All right. And over here, I'm going to say board pins, right? I'm going to change this to, I'm going to make it all small letters, max, right? And I'm going to call this EZ. So I'm pretty much overwriting, and I'm going to use 2209. Okay. Next, I need to do all of this configuration. Now, I'm going to show you one or two of these, and then I'm going to take this whole selection and delete it and paste it in so that we don't sit here the whole night watching me look for the pins. This is something you need to learn on your board, and every board is going to be different. So if you're using custom boards, you're going to have to come in and fill these in. They do recommend that you actually use the pins directly inside the main structure, but I actually like this way that they use aliases, and because the whole system is built on the structure, that's why I'm creating my separate file in this case, and I'm going to then actually, can I say, specifically link it to my board's item. So what I'm going to quickly do is I'm just going to open up another image over here. I'm actually going to open up the PDF document for my board. Just give me a second. Let me just make sure I get it right. And I will bring it over here. You can just see that for now. Let me just check that you can see it. Yes, you can see it. Right, so inside this is the board, octopus board that I've got over here. Obviously it's just slightly turned. We could rotate it, but there's my 10 motors, right? And what we're looking for is where we're going to be plugging our motors in. Now, because my extruder, where plastic gets pushed through, is going to be connected to the tool board, I am going to only need 5 motors on the main board, right? So what I've decided to use is motor 1, motor 2. Basically that's for X and Y on my side, and then I'm going to use motor 8, 9 and 10 for my Z, for my bed up and down, right? For the tri-level bed that we're going to be implementing. Oh, some work stuff. While we're looking at those motors, we need to see certain pins. Now, let me just maybe zoom even further in on this section. Right. So here we have motor 1, which is the first one on the list. Maybe I'll point like that, then you can see it a little bit, right? And motor 2, which is that one there. And you can see that the step and the direction pins are indicated for each motor, right? If I come back here to X step pin, X motor step pin, right? What is my X motor step pin? My X motor step pin is PC13. Okay, so I would now have to go inside there and modify that to PC13. Next, I would need the direction pin, which would be PC14. So I come over here and I go PC14. And then it's going to ask for the enable pin, which is P6. Right, we go to P6. And let me move this a little bit like that. The next pin would be my, oops, sorry. I'm just trying to see which is the best way to put this. Let's just put that on that side for a moment. My UART pin is this CS, all right, which is basically the control pin. And I'm going to change that to PG14. Then for now, you're going to have to look for your diag pin and your end stop pin. Now you can see on these boards, I think on some boards it's actually separate, but on this board it was the same. And on my board it is, I'm also using the same. So if I now go back into this drawing and I just go out, I'm looking for my end stop pin, right? There's my end stop pin, And let's say, for argument's sake, I was going to use the first in-stop plug, then PF0 would have been the pin that I would have needed for the in-stop, right? For X, and if I was going to use Y in-stops as well, I would use it. In my case, I'm actually not going to use in-stop pins. I'm going to be using sensorless homing. So I'm actually not going to connect this, but I'm going to put the diag pin at least in, because the diag pin is required for sensorless homing, and I will put in the same value for the in-stop pin, but you'll see at this stage I'm actually going to remove comment it out. So sorry, that was it was PF0. We're going to come in here, we're going to go PF0 and PF0. Okay, so that's for the X. Now I go for Y. Now same process again. Basically, let's move across to the motor, and we're going to take the step being PC1. Just want to try and move this out of the way again. Oops. All right. So for motor 1, step would be PE4. So I'd come here and change PE4, and so on until I get to the end of my board, right? I'm not going to do all of these. This would have been motor 8. This would have been motor 9. This would have been motor 10. They've got an extra Z because if you were building a Voron 2.4, you use 4 motors to level your gantry. So you would have a fourth Z, meaning 0, 1, 2, 3, and Z3 being the 4th motor. You would use those diag pins. And if you were going to put your extruder motor where your plastic is going to come through directly onto this board, you would also set up that extruder on your settings, right? Stepper SPI pins. These are if you're going to use the SPI bus for any reason, and typically the SPI bus, in most people's cases, they would probably use that for the ADXL connectivity. Because I'm going to be using the toolboard, inside this little toolboard with all its powerful and packed so small, right, is an ADXL accelerometer as well. So I'm not going to set up the accelerometer on the main board. I'm going to set it up on the small board, and I'll show you to that in a little while. Okay. You might need to go back and forth on this video a little bit because I'm trying to cover quite a bit. So when you finish with setting all that up, in my case, I'm going to pretty much remove those because I don't need them. I'm only going to be using that, and I'm actually not even going to be using the accelerometer. So what I've done is, prior to this, I actually went and did the same for the ADXL pin. Oh, right. So the ADXL pin, yeah, I wasn't going to use the ADXL, so I'm just going to comment it out. For the auto leveling, I was not going to use the BL Touch. I was just going to use a Pinder probe. For fans, because I'm using the toolboard again, I'm not going to be using the part cooling fan over here, and I'm not going to be using the tool fanning because that's all on the small board again. That's all on the tool board. So these values become not required for me. And remember, I'm building this as if RatRig would have built this file now. They would have done all this modification, customization. I'm customizing this for my own board. That's why it's so much different to what you would do if you were just using your own board, because you wouldn't have one of the standard boards, but you wouldn't have to do this. But okay, here we go. Keep going. My bed heater, right? So I would need to have the heater gets connected to this board still, and the bed sensor, the heater sensor, also would be connected to this. So I would then come back to my file over here, and I would now need to look for the heater pin, right? And on here you will see there's bed out, right? And bed out is PF5, right? So the heat, this would be PF5. Oh, and our mascot cat has arrived. He's come back to see if he can walk over all my stuff, so I'm going to have to push him off. Say hello to everybody, and now say goodbye, please. There you go, sit in that basket. Hopefully he stays down there. Mr. Smokey. Then the actual heater thermistor, right? We need to know where the thermistor is. So let's go and have a look on the board, and there's the heater elements, right? And let's have a look if we can see. There's my thermistors where I can connect different probes to, so I can read temperature, and in this case it's these values over here, and you'll see THB, which is typically the board, your bed heater, gets connected to the first one, and then TH0 would be your first extruder. And if you were running a multiple extruder machine where you had different extruders connected for multiple carrier printing, you would be able to connect more than one thermistor. Or if you're going to, like me, maybe in the future, I'm actually going to run a thermistor inside, because I'm going to heat my chamber. I'm actually going to use one of these thermistor connections to measure the temperature inside my enclosure. So in this case, the bed is connected to PB1, so we'll just change that to PB1. Okay, you get the hang of it. You're going to go through this. On this board, there is no expander header for a screen because this board doesn't come with it, so I would delete this in this case. What I'm now going to quickly do is shortcut all of that, because I really want to get to the point where I actually push the button. And I'm going to take this, and I'm going to paste it over here. And by that you'll see I've even uncommented some of the things. At a later stage I'm actually going to clean this up because I don't need it, but you could just leave it just comment it out. It would make sense. It would still make sense and still work, right? Then the next thing is the MCU, right? Now the MCU is the actual the serial number of the board. That's why it's giving an error. It can't find the board because it doesn't know where the board is connected to the PI at. And because you would have used a stock board, it would have found it. Because I'm not using a stock board, I go into my SSH session. I'm not going to cover this. There's many videos covering this, how to do this. But if you go inside here, you could ideally get your board's actual serial path. There, I'm grabbing it over there. That's the one I want, and I'm going to paste that in there. Okay, that now will identify my board. Whoops, we don't need all of that. Coming to the rest of this phone, this was the temperature sensor on the Octopus Pro board. Again, I'm just going to rename this to its more display name so that I know what I'm looking at. I'm going to say Max EZ. It's just a label in this case. That's going to measure the temperature. And for the ADXL, again, I said I'm not going to be using the ADXL. You can see I've already commented out the SPI pins, and initially most people won't be using it, but in my case I'm definitely not going to be using it, so I'm just going to comment that out for now, or I could just delete it in my case. Right, remember, this is my config file. RatOS is not going to overwrite my config file. So with that in line, I can now actually save and close this file, because I've come to the end of this configuration file. And what I want to do is now come back one level and actually come back into my printer CFG, and yeah, where we would have included those files, we're now going to include my file. So let me just take that, paste it in there. Okay, and mine is not in that folder, it is in RS files. Files, what did I do? File or files? Let me just double check on the other screen. I said files. Okay, and be careful, case sensitivity is very important over here. It's not under boards. I've just gone directly for a CFG, config CFG. So in that folder, open up that file, and that's where I'm going to get my board stats. Okay, so I'm just going to save and close here. You remember we had unable to connect to the MCU. So I'm now going to do, if you were in the side here and you click save and restart, it'll actually try and restart the Clipper session, and you'll start seeing different errors coming up now. All right, so let's not worry about this now. For now, we're going to continue, and we're going to come back here. I just want to double check that I've got that section right. I'm just doing it on the other screen. Just give me a moment. I just want to double check that I haven't missed something over there. Okay, seems fine. All right, coming to the base setup. Remember, I chose the V-Core3. It's already included the V-Core3 configuration, homing macros. It's some shells and some more V-Core3 specific macros for that. So this is the configuration for the V-Core3, meaning size and things like that. And this is the actual macros that they wrote for that. Now, stepper motors, we're going to leave that in place because I'm using the standard stepper motors that came with. So the motors that are there, I'm using a TMC 2209. There are two sections here, uncooled and cooled. I haven't got a fan on the board yet, and I won't have it initially, but eventually I will. So at some stage I'm going to comment all of these out, and I am going to uncomment that, and this pretty much just pushes up the motor torque and acceleration and makes your motors move a little faster so you can print a little bit faster, right? It's just higher performance settings at this point in time. I'm going to leave that just on the default. Then we come to stealth chop mode. Stealth chop mode. If your printer's making lots of noise, you can come here and you can uncomment these, and what it's actually going to do is reduce your speed a little bit, but it'll make the machines a lot quieter, but less accurate. Just take that into account. Now, how much more inaccurate? Oh, it's not that big, but so if you're into accuracy, deal with the noise. If you're not big into accuracy and you just want to print nice little toys and things like that, welcome, switch it on. It makes a big difference. Much quieter, right? Physical dimensions of your printer. I'm using the V-Core 500, so I'm going to uncomment that one. Comment that one out and uncomment the 500. Yeah, we get into the homing. I'm not going to be using the BL Touch. I am going to be using the inductive probe. In actual fact, I have a beacon on its way. I'm going to be using the beacon, but for now we'll just keep with the probe because that's what I have. And I'm not going to use any of the other probes, but you can just select them if you changed your mind. I'm not going to use a physical end stop, right? So I'm taking out the physical end stops because I'm not going to use them. I'm going to use the sensorless homing. So what they do say over here is if you're going to use the sensorless homing, first of all, you need to know how to use it. You need a bit of experience. So it's better to start with the M stops. And then once you're comfortable, you can come back and then do sensorless homing later on. I've done sensorless homing on 2 of my other printers, so I'm okay with it. But what they want us to do is actually copy the sensorless homing config from the templates to the root directory. So let's go and do that quickly. I'm just going to save and close this so that I don't lose my settings. I'm going to, on the side here, because I've downloaded this file 5 or 6 times, I'm just going to wipe it out so that you don't see the wrong file when I'm busy. And coming back, we're going into RatOS, we're going to the templates, and there is the sensorless homing. Now, if I was only going to do sensorless on X or only on Y, I would have used one of these files, but because I'm going to use both X and Y, I'm going to use this file. And the easiest I found is to right click on it and download, right? Downloads the file. There's your file downloaded, right? Oh, Chrome moans that it could be dangerous if you can just click on keep and then the file is actually downloaded. So in my download folder on my PC, it's sitting there. And then I can come back, upper path, back to the root where we were. And then I can upload the file. And I can go and choose, definitely not that folder, that config file that we've just downloaded, I can put in there and include. There it's imported it, right? Just for interest's sake, if I go inside here, what is inside? There's not much to modify here. At this point in time, what we will do at a later stage is probably, well, if you've changed to different types of motors, you would have to come and change some of the motors over here. But this parameter over here, we will adjust later on when you've got your printer up and running. At now, they've put best default values. I sort of agree. Mine was 72 last time and 83, 85. So these ones seem pretty good, pretty safe. I'm just going to stick with them for now. Right? I'm not going to do any changes there. So nothing much for me to change there. Come back to my printer CFG file and get back to this. Now, because I've copied that file across, I can uncomment that. I'm not going to do X and Y separately, so just leave those commented. Input shaper is part of, you need the ADXL45. Remember, I'm not connecting this input shaper to my main board. I'm going to be using it on the toolboard. So for now, I'm going to leave this. I'll come back to it in a couple of minutes, maybe. Now it's asking me what tool head I'm going to be using. In my case, for my printer, I'm going to be using the Orbiter 2, which is, oops, we definitely don't want that, which is this motor there. Yeah, they say if it's got this specific motor on it. Yes, I have that motor. On my hot end, I am not using the Rapido. I will be using a Revo. Don't judge me. I like the Revo so far, and I'm just having the high flow Revos shipped to me as well. Fans, part cooling fans. Right now, this is if you're going to use 4-pin part cooling fans. Again, part cooling is if it's connected to the main board. I'm not using part cooling on the main board. I'm not using the tool head cooling because that's on my second board. And at some point when I do buy fans, if I do go with 4-pin fans, meaning fans that have got 4 wires to control them, which means it's got ground, power, tack, and sense. It's got 4 different connections that connect to the board. You would come back and uncomment this. At this point, I'm probably just going to use the 2-pin fans at some point, so this section means nothing to me for that. Again, I don't need to remove it. I just leave it where it's in place. Macro configuration, nothing to change over here. We're going to use the standard settings that they have. We can maybe come back and calibrate and change this at a later stage to our likings, but for now the defaults are fine. In terms of the printer configuration, if I had a motor that was turning the wrong direction, I could come over here and I could then put exclamation in front. That would then change the direction of the motor. At this point, I don't know if it's right or wrong, so I'm going to leave it like that. Only when I have the motors connected can I can check. And the default rotation distance on these will be 40 for a 20 tooth, which is the standard pulleys that they pull with. If you've got the smaller pulleys, then you need to just change the rotation distance. This I'm also going to calibrate at a later stage. I've got quite a few calibrations that I'll be going through, and I'd like to, at that stage, look at that number a little bit closer and see if it's actually accurate. Again, same for Z over here. They ask the rotation is 4 on a TR8 lead screw. If you were going to do a BL touch, you would come and offset that. Because I'm doing the inductive probe, this is fine, and I am going to be using basically the super pinder that came with it, but at a later stage I will be using the beacon, right? And because I'll be using the beacon, then this will change a little bit, most likely. Actually, this might not change with the beacon. This might remain the same. Although your offsets, we have to adjust this offset. This offset I'll do later once I've got the printer up and running, and I know that the movements are there. That's part of your initial setup to set the offsets. Your extruder, right? So this is for advanced pressure testing. Just the general settings. I'm going to be using a 0.4 nozzle. This is in case the motor is turning the wrong direction. These are the default PID, but we're going to do a PID tune, and this will change in any case. Same for the heater bed. We'll do a PID tuning later, and this will automatically calculate these values. So don't worry about these values for now. As again I said, ADXL, I'm not going to be putting that in for now. Although I might actually need this one. Let's go to the toolboard first, and we might come back to that one as well. So under the toolboard, and this is this little toolboard that I got over here. Okay, this is very important for me to get this up and running, because I'm only going to run 2 power and 1 USB cable to the tool head. The rest will be controlled via the little board where everything's connected. So I have the EBB 42 version 1.2, so I can uncomment. Oh my goodness, uncomment, right? And sorry, my work guys at the office are busy sorting out issues, and because we have a toolboard installed, we have to uncomment that one. We are not going to use the actual BL touch. We are going to use the probe. Right now, there's a probe section here, and there's a probe section here. So which probe section do you want? Well, these settings and these settings are all under probe. You can have the probe section multiple times and just add one line item under that, and then later on say probe again, and then change that. Typically you would group all the things, but because they want us to do the stuff under the toolboard, so I'm now going to come back here and say, right, we are going to use the probe, and I'm going to use the super pinder right on the toolboard. Now I go back to over here. It would make no sense for me to include the pin over here, okay, because my probe is not connected to my main board. So now I'm going to switch that off. But Z offset I'm going to leave in place, because Z offset is valid whether it's on this board or on the small board. It's irrelevant. Okay, and now the pin will go through, and if yeah, it should be fine. Okay, if you need to change the direction of your extruder, right, you can change it over here. Otherwise, if the plastic's pushing in the right direction, you don't need to change this. If it's not going in the right direction, all you're going to do is to comment that out, and then by default Whatever setting was before, this will override it because it's later on in the file. Okay. If you have N-stop X connected to your toolboard, I don't have the N-stop because I'm sensorless homing, so not needed. And to use the toolboard's ADXL for resonance testing, uncomment the following. Right, so now we need to include the toolboard input shaper. Right, I want to now go back just to input shaper over here, because I'm going to do resonance testing, right? Even though I've included this, I'm almost certain I might need to still indicate where to do the probe points. And the probe points on the 500 will be there, right? So I needed that uncommented. Further back, if we go up to, where did I see it? Where's the other resonance tester? Did I miss it now again? There's the other instrument. You would see, had you included it at this stage, it would have been with reference to your main board, and it would have included the V-Core3 input shaper file. But because we've connected it to the tool head, it's gone to the toolboard import shaper. So it's very important that you don't just uncomment files by accident. And that's it. I've pretty much got to the end of this. So let's see what happens when I push save and restart. Option serial in section must be specified. Why am I getting this error? Because let me just think about this for a second. Go back in here and go find serial. Oh, guys, look what I've done. I included this file, right? But I never uncommented it, so it was never looking at my file. That would make sense. I need to make sure that my control board, my specific board, is now there. So let's try that again and see what that does. Right, you can see that looks totally different now. That actually started up, and we have successfully, forget about this for a second, we have successfully connected to the STM723, which is my main board, right? Which is that processor over there, the MCU there. And we've also connected to the tool board, right? Which is this little board over here. Okay, and that's now found those two boards, and it's happy to report on them, their temperatures. Why has this then come up now? So if you actually take this error and you Google it, it'll come up with this. This generally occurs when a heater temperature exceeds its config min or max, right? And what you will see is, because we don't have any probe connected to our heater board, so there's no thermistor connected to the heater board, the heater board doesn't actually know what temperatures. Is it -50, 0, +100? It's an open connection. So that's why it's giving us this error at this point in time. If you get to this one, you're good. That's all you need to get to. From this point onwards, you're now pretty much ready to take your board and install it in your printer. That was a mouthful. And I still made it sort of just on 9 o'clock. As I said, we'll probably be slightly over. If I was to now plug this in, I am assuming there will be a couple of more configurations, but at least the base configuration will go up. And had it been connected, we would have not seen this, and we would have just seen connected, and we would have been able to go to the dashboard, and we would have been able to home or start our processes. please, when you do get to that point where you've connected everything, and I'll repeat it later on when I've got it inside the board, don't click on the home button and just start. Okay, there's some pre-checks that you want to do, small steps to make sure that you're not going to damage your printer on the first time that you click a button, right? We're going to check motors, fans. We're going to buzz motors, let them move left and right a little bit, just to make sure that everything's working the way we think it should work before we go for a full blown homing. Okay, that's what I wanted to cover tonight. Important that you get, if you're going to do customization, because you are using a non-standard board, it's important that you get acquainted with all your pinouts and how it works. Also, you're going to need to learn to go through your board's specific connectivity connections. Things like your diag pins will differ. Every board will have a different way of using that. You still need to go through all of this before you actually plug that board, mount that board. Make sure you've got all the connectors right, all the jumpers correct. You've got your voltages selected correctly. You're going to be using the right thermistors for reading the temperature. Yeah, get acquainted with your board. I will just give you one further pointer. If you're using a standard board, and we go back here, and let's go to back into the RatOS, and we go to boards. RatOS team have done an amazing job of actually documenting. Let's say, for argument's sake, we were going to use this board, right? If I open up that board, inside there, while there is config, and I'm not going to change anything here, there is a wiring diagram that you can reopen over here, and they've already pretty much documented it as much as possible for you, saying, okay, your left motor is going to go here, your right motor is here, your extruder's there, there's your 3Z motors. If you're going to use an ADXL on the board, you're going to connect it exactly over there. You can actually download these images and you can get these pins. It doesn't zoom very well on the browser, okay? It like just stretches this way. It doesn't actually zoom in for some other reason. I can't understand why. But it'll show you where to connect everything. They've done a lot of this documentation for you. Go and have a look at those images. It really makes a difference to have a look at the images. If you wanted to know how to get your board into DFU, they give you the images what to push. There's enough images over here to get you up and running with your wiring as well. But also, if you go to this website, and let's say you were inside, yeah, and there's that same board, click on that, and there's that same diagram, right? And you can now go in and out. Okay, again, zooming doesn't want to work for some other reason. I can't understand why. But there's that same documentation, and then they're also going to give you further information. You need to read all of this information prior to even starting with the firmware. Make sure you've read everything about your board. Okay? They give you a lot of information to use. Right, I don't think I can cover too much more. That's it. The next time you see me, I'll have the printer back on the table, and we will start attaching different devices to the printer. We'll start. I will starting to put all my DIN rails, attaching my DIN rails. In order not to take too much time on the next video, I will pre-drill all of this prior to the video. But I'll screw all of that in front of everybody, and to show you what I did in terms of spacing. We'll connect everything, lay it all out, and then we get to wiring. And that's quite exciting. That's also because actually you can see a lot of progress quickly. Firmware just takes a lot of time, but it's something that you need to be very, very, very clear on and get it right before you plug this into anything, right? And that's why I like doing it on the table over here. Please remember, if you're working with the PSU, the power supplies and your ACs, and you're not comfortable, get someone to help you with the AC connectivity. Someone that's got a bit of electronics experience would really be helpful. Even join you on the project and joining to build, put this last piece together. It's quite fun to do together with other people. If you have someone that has that, Terry that's on the line here actually sat and helped me wire and crimp my previous printer. It was a good evening. We really enjoyed the chat, and it was just nice to bounce thoughts off him as we were doing the crimping. Okay, I'm going to finish there. I wish you all a pleasant evening, day, wherever you're watching. Remember to please like this video and subscribe if you haven't done already, and we'll see you next time. Cheers.